I want to show how to interchange two finite sums where the range of the second sum depends on the index of the first sum. I'm going to take as an example a sum of y less than or equal to x, and then a sum of z less than or equal to y. There are a few details about this sum that I want to point out before we begin. The first is that it's implied that x is fixed in this expression. In this case, I also mean that the sum over y is the sum from some minimal element up to the value x. We represent this outer sum by a ray for the range of y, and then we draw a red segment to indicate the range of y from a minimal element to the value of x. Now the variable z is also represented by a second dimension. The inner sum over z ranges from some minimal value from the red segment to the line y equals z. The region that we are summing over is the area between the red segment and the line y equals z. Now let's do the same sum over the same region, but instead we sum in the z direction first. That is, we first sum over z from the minimal value to x, and we first determine this x by looking at the maximum range of z in our first picture. Next, for each value of z, we trace over the possible values of y. That is, we trace out over the same region. For this to happen, y ranges from the line z equals y to the value x. We have that switching the sums then is equal to the sum over z less than or equal to x and the sum over y in the range from z to x. This method of drawing pictures is what we'll use to interchange all kinds of sums, and the sums will be equal if they trace out over the same region.